Why does Apple manufacture all of their chips on this one tiny island? How did one man at the lowest point in his career build the best chip maker in the world? How could he do it in a country with no track record in semiconductors to speak of? And what's next for the company that powers the world? Today, the unbelievable story of TSMC.
TSMC warns an invasion of the island would render its factory inoperable.
We are the only provider on the planet of this critical technology.
Xi Jinping could feel they have no choice but to use force in some way to take Taiwan back.
台独分裂是祖国统一的最大障碍。
I want to begin this story in an unusual place, the modern day, because it's where we can best understand the scale of what TSMC has achieved. For everyone who works in technologically advanced manufacturing, two issues are causing more headaches than almost anything else: the semiconductor shortage and the escalating strategic competition between China and the United States. TSMC is a central player in both of these dramas. The semiconductor shortage has several causes: supply chain disruptions, strategic competition, a faster than expected economic recovery. TSMC, like many companies, hasn't been immune. But very few companies can announce plans to spend more than $100 billion in capex. When that new capacity comes online, it will make a big dent in meeting global demand for the chips that power everything from cars and consumer electronics to medical devices and military weaponry. No other company can really power broad industrial production capacity like that. Secondly, TSMC is so important to the global chip ecosystem and to Taiwan that it creates its own geopolitical gravity. Most analysts now believe that China's incredible rise makes some kind of confrontation with the United States highly likely. Both countries have raised trade barriers and plowed huge amounts of money into developing key strategic industries. But the semiconductor industry, which they are both reliant on, is interconnected. Here's a picture of how semiconductors get made. Design happens in the United States, manufacturing is done in Taiwan, but key ingredients needed to make them are sourced from Japan and Germany, and final assembly often takes place in China. The supply chain is long and as delicate as the chips made by TSMC. TSMC is so important to this globally critical industry that it forms a big part of Taiwan's strategy of deterrence against the threat of Chinese invasion. In fact, this strategy is so widely understood that it has its own name, the Silicon Shield. TSMC is too big to fail. It's not just essential to our cars, electronics, and armies, it's essential to Taiwan. Nothing like this was even remotely on the horizon when Morris Chang was born in July of 1931 in southeastern China. It's fitting that a figure who is so important to the economies of both China and the United States today would have a personal history so closely tied to both. Morris's childhood was defined by war, 3 of them in fact. First was the Sino-Japanese War. Morris and his family had to flee from Japanese air raids in Guangzhou. By the beginning of World War II, the family had escaped to Hong Kong. However, their new home was attacked by the Japanese on the same day as the attack on Pearl Harbor. Morris and his mother had to live through shelling, gunfire, and later Japanese occupation. By the time the family had relocated to Shanghai, China was consumed by civil war. Despite being middle class by the standards of the day, Morris's family was not well off. He saw despair, poverty, and injustice everywhere he looked. That motivated him to study hard, and later in his life to work hard. When he was 18, Morris was accepted to Harvard. He described his reaction as sheer ecstasy and almost disbelief. Part of that disbelief was because Harvard didn't have that many students who looked like Morris. Harvard was great at producing social and academic elites, lawyers, accountants, and politicians. It wasn't as great at producing engineers. In fact, it didn't offer an undergrad engineering program at all. And Morris already knew that he wanted to be an engineer. So after his first year, he transferred to MIT and quickly completed his bachelor's and master's degrees in mechanical engineering. Morris was planning to continue on to do his PhD, but he encountered an unexpected hurdle. He failed his qualifying exams. In fact, he failed them twice. So, unable to continue with his studies, Morris went out to look for an engineering job. The semiconductor industry back then looked absolutely nothing like today. Early transistors were available, but integrated circuits wouldn't be prototyped until the late 1950s. And the work was being done in germanium, not silicon. It's not clear how much Morris knew about this at the time. He was a mechanical engineer, not an electrical engineer. Despite this, he accepted an offer from Sylvania Electric Products, which had just established a semiconductor division. Morris worked at Sylvania for 3 years. He worked hard. But he realized that the sales team was over-promising and the product team was under-delivering. When he heard a senior manager say that we cannot make what we sell and we cannot sell what we make, he knew that it was time to move on. He'd heard good things about a company in Texas. Today, if you know about Texas Instruments, you probably know them as a manufacturer of graphing calculators. But back then, they were a juggernaut. They got their start making devices for measuring seismic activity for oil exploration. That desire to power the future of industry led them into computing and semiconductors. In 1958, Morris received an offer to join as an engineering supervisor with responsibility for a production line. It didn't take long for him to score his first win. The production line that Morris was in charge of made chips for IBM. IBM was working on a product that they thought would represent a big leap forward, its first mainframe computer. It used transistors instead of vacuum tubes. Anticipating high demand, IBM partially outsourced chip production to Texas Instruments. This was the first iteration of the basic pattern that would eventually define Morris's career. A company making ambitious hardware outsourcing chip production to a company he worked for. IBM's own plant was producing chips with a yield of about 10%. Let's discuss what we mean by yield in semiconductor production, because this won't be the last time we discuss it. Yield refers to the usable output generated by a production process. In a process as delicate and complex as semiconductor manufacturing, small defects accumulate into huge error rates. A 10% yield meant that 9 out of the 10 chips that IBM was producing were failing. It got even worse. When Morris came on board, the yield of his line, it was about 0%. But he'd acquired some knowledge from 3 years at Sylvania and his own self-directed study. So, like a chef, he experimented with the recipe. After enough changes, Morris was able to improve the yield of his line from virtually 0 to about 20%. That's tiny compared to today's top fabs. But it was a big deal for Texas Instruments, IBM, and Morris Chang. Suddenly, everyone at Texas Instruments knew his name. IBM initially thought Morris had gotten lucky, but when they sent engineers to talk to him, they realized this guy knew what he was doing. Morris described the theories he'd been testing and why his experimental process had worked. He wasn't just throwing darts at a dartboard, he was iterating successfully. By 1961, thanks to these achievements, Morris had been promoted to be the manager of a big engineering section working on germanium transistor development. Eager to support their rising star, Texas Instruments offered to pay for Morris to complete his PhD. He accepted the offer and returned to Stanford for 2.5 years. This time, he passed his qualifying exam with flying colors. A few months after his return, the vice president of the semiconductor division asked him to head up an entire product department. All of a sudden, Morris was a general manager, in charge of more than 2,000 people. He was well and truly on the fast track. One of his signature achievements in his first GM role was to complete the development of one of those germanium transistors he started working on after returning from Stanford. Texas Instruments began manufacturing that transistor at scale to sell to its most important client, IBM. Morris had made another highly lucrative contribution to the business. Morris was moved from less important to more important departments, and by early 1967, he was the general manager of the Integrated Circuits Department, the most important semiconductor department at all of Texas Instruments. Morris had already made technological breakthroughs. His next breakthrough would come on the business side. In the late 1960s, when Texas Instruments or any other semiconductor company began a new product line, it immediately charged its customers a lot of money. On the face of it, this was rational. After all, new products required massive upfront investment. But Morris, with the forensic problem-solving style that was rapidly becoming his trademark, realized this approach wasn't optimal. It wasn't optimal because at this early stage of production, maximizing revenue couldn't be achieved by increasing the price. It would be achieved by maximizing the yield. How could you maximize yield? By maximizing production volume. Morris borrowed from his own experience to realize that improving yields was a learning process. You needed to solve novel, interconnected, difficult problems. He realized that the key to improving yield was to maximize the opportunities to find the problem and identify the solution. And the best way to do that was to make as many chips as possible, as fast as possible. Basically, Morris reasoned, you always want maximum capacity. Morris hired the Boston Consulting Group to formalize his thinking. The outcome was learning curve pricing, a model that sets prices low at first in order to quickly kickstart manufacturing volume and rapidly increase production yields. Remember that idea, because we'll come back to it later. A happy side effect was that, by initially setting the price low, Texas Instruments was also able to grab lots of market share. Morris had made a key realization, one that is still just as relevant today. Sales and product aren't separate silos, they're highly complementary. You need a great product, but you need a great business model too. Morris's insight and the work of the Boston Consulting Group made Texas Instruments' integrated circuits department the biggest and most profitable integrated circuits business in the world. Much of the credit belonged to Morris. He had learned the technology and business of this rapidly evolving industry better than anyone. In 1972, Texas Instruments rewarded his accomplishments by promoting him to vice president. Morris was now responsible for Texas Instruments' entire semiconductor business. It capped an incredible rise for a man who had left his home to come to the United States when he was just 18. Morris remained in that role for 6 years until he transferred to the Consumer Products Division. And although it didn't seem that way at the time, this is where things started going wrong for Morris. Management could sense that a market for consumer electronics was emerging. Remember how I said that today Texas Instruments is probably best known for calculators? This is the kind of direction the company wanted to head in. The Consumer Products Department hadn't gotten off to a great start, but Morris's bosses, figuring that a good manager would be a good manager anywhere, moved him over to the new department. It was a mistake. The products were different, the customers were different, the market was different, and Morris couldn't turn things around. So 5 years after being moved to Consumer Products, he was transferred to a job as VP for Quality and People Effectiveness. It was a staff job basically, almost HR. For Morris, it was a slap in the face, especially given he had essentially built Texas Instruments into a world leader in semiconductors. This bad news was about to be compounded. Perhaps because of its focus on trying to turn around its consumer products division, Texas Instruments was caught off guard by a combination of an industry-wide transition to metal oxide semiconductor manufacturing, leakage of talent, and the sharp response of its biggest competitors. It lost their advantage in semiconductors, the advantage Morris had worked so hard to build. He could see the writing on the wall. From being the guy everyone thought would be the next CEO, Morris's career at Texas Instruments was basically over. He'd been put out to pasture. In 1983, he resigned. 30 years of service over in an instant. Of course, it wasn't lost on other companies that one of the world's best semiconductor engineers was suddenly unemployed. Morris's phone started ringing. One of the calls he fielded was from General Instrument. They weren't quite as big as Texas Instruments, but they were still Fortune 500 big. They offered him the role of President and Chief Operating Officer. He accepted and moved to Manhattan, but it was a total bust. Morris believed he was joining a company similar to where he'd just been. The reality was very different. He quickly realized that General Instrument functioned more like a private equity firm than a semiconductor business. Instead of growing organically, General Instrument's business model focused on mergers, acquisitions, and either incorporating the acquired business into the parent company or flipping them for a profit. So after just 1 year at General Instrument, Morris decided to leave. He was crestfallen. Here's a quote from him describing his mood at the time. After these two setbacks at TI and GI, I did not think that my aspiration to be the CEO of a major US company was in the cards. He was right, just not in the way he or anyone else could have expected. Morris Chang was in his mid-50s and had a reputation no one ever wants, former rising star. Things weren't totally terrible, he was financially comfortable, but the phone wasn't ringing off the hook like it was after he left Texas Instruments. However, an opportunity was about to emerge from an unlikely place. In the 1970s, when he was still at Texas Instruments, Morris had traveled to Taiwan a couple of times to meet with government officials to discuss building a manufacturing plant. They clearly remembered him because they offered him the job of president of the Industrial Technology Research Institute. ITRI was the Taiwanese government's effort to answer one of the most important questions facing any developing country: how to sustainably raise its standard of living. Remember, back then, Taiwan didn't have the first-rate economy it does today. Its strengths were in agricultural products and low-value manufactured goods. The government of the day was committed to moving up the value chain. It knew that in order to accomplish that goal, it would need to develop cutting-edge capabilities in higher-value technologies like semiconductors. ITRI was established with the mandate to conduct applied scientific research for industrial purposes and then spin off the successful products as private companies. In 1975, Taiwan negotiated the transfer of a semiconductor technology license from RCA, a big American electronics company. It was about a generation behind the cutting-edge manufacturing technologies of the day, which were dominated by companies like Intel, Fairchild, and Texas Instruments. But it was a start. In fact, ITRI was able to use this technology to establish and then spin off Taiwan's first ever semiconductor foundry, United Microelectronics Corporation, or UMC. It was against this backdrop that Morris was offered the job at ITRI. It's really interesting to hear him describe his reaction. He saw it as a completely new kind of job in a totally different environment. That difference appealed to him. Besides, Morris reasoned, he was financially secure. He could afford to roll the dice. So in 1985, Morris became president of ITRI. The early days were not easy. Remember, Morris was a foreigner. He was born in mainland China, and he'd learned everything he knew about semiconductors in the United States. But he was making progress sharing his knowledge and transforming ITRI into a high-performing organization. One day, he was approached by Li Kuo-ting. Li was an incredibly important figure in Taiwan's economic development. After more than a decade as economy minister and finance minister, by the time Morris arrived, his remit had shifted to promoting science and technology in Taiwan. Li approached Morris with a pitch. Here was the thinking. Morris had lots of experience managing large semiconductor businesses. Taiwan's government wanted to develop expertise in semiconductors. They had the manufacturing technology which they had licensed from RCA. Plus, they were willing to write Morris what was effectively a blank check. Besides, as Morris put it, this was an offer he couldn't refuse. Li gave him about 4 days to develop a business plan. No time to waste then. In an interview about his life, which he gave to the Computer History Museum, Morris explained that he began by reflecting on what they had in Taiwan. His conclusion was very blunt. They had very little strength in R&D, none in integrated circuit design, not much in sales and marketing, and very little in intellectual property. What Taiwan did have, however, was a potential competitive advantage in semiconductor wafer manufacturing. Morris decided to start a company that would fit Taiwan's strengths and avoid its weaknesses. A pure-play foundry, a company that only made chips. There was just one catch. There was no evidence that a market for a company like this existed. But Morris knew this wasn't proof that a market would never exist. In fact, his experience made him think otherwise. He remembered back to his time at Texas Instruments, where he encountered lots of integrated circuit designers who were itching to start their own companies but couldn't raise the money. The reason? Investors couldn't envision a semiconductor company that didn't also make its own chips. In the 1980s, it cost between $50 and $100 million to start a new chip company. Most of that was the cost of manufacturing, and those potential founders who Morris had met simply couldn't raise that kind of funding. An alternative was to contract production from one of the big players. But not only was that unreliable, you were also lining the pockets of your rivals. Neither of these were great options. Morris thought that a pure-play foundry could be a solution. By removing the need for every semiconductor startup to build its own fab, maybe more of these aspiring designers could actually form their own companies, and then maybe they'd become TSMC customers. He believed, hoped really, that a new market would emerge. It was a completely novel idea. At the time, all chip manufacturing was integrated. The few companies out there that did focus on chip design had to fight for table scraps. Morris was under no misapprehensions. Everyone, including him, realized his plan was a long shot. But he believed the concept had merit, and he trusted in his 30 years of experience in the semiconductor business. Morris's bosses, who were the bosses of Taiwan, remember, listened to his presentation. Okay, they said, set up a pure-play foundry. But we know it'll take a lot of money. We're only good for half. You have to raise the other half. Oh, and we want you to raise most of it from big players like Intel or Texas Instruments. Talk about a tough ask. Morris met with Texas Instruments and Intel, but they couldn't see what he saw. So having exhausted basically every other option, he met with the Dutch electronics manufacturer Philips. Philips agreed to put up 28% of the capital. They also shared some key information on the 1.5 micron lithography process, which was used by the major semiconductor companies in the mid-1980s. Some local businessmen were also, let's say, strongly encouraged to invest by the Taiwanese government. In the end, Morris succeeded in raising half of the $220 million that TSMC began its life with. TSMC, Taiwan's semiconductor manufacturing company, began operations in 1987 with Morris Chang as its founder and inaugural CEO. For the first 4 years of its life, TSMC depended on other companies throwing them small orders. The dregs, basically. Viability, let alone market dominance, looked a very long way away. But then something began to change. Morris Chang was almost washed up. It was a brutal judgment after 30 years on the leading edge of the semiconductor industry. But we're talking about a brutal industry. One wrong step, failing to turn around the struggling consumer products division at Texas Instruments, turned into another with his ill-fated move to General Instruments. A lot of people believed that moving to Taiwan to try and build a semiconductor industry from the ground up would be his third strike. After all, he was already in his mid-50s and trying to get ahead in a young man's world. All of this is what makes the second act of Morris's career, the one where he turned TSMC from a moonshot into the world's 9th largest company and a linchpin of Taiwan national defense, so utterly incredible. It's a sequence of events that a movie scriptwriter would laugh at. As I just mentioned, 4 years in, things were beginning to change for TSMC. Morris was working hard, evangelizing, cajoling, and just generally twisting elbows. He spent a lot of time talking to people who wanted to start their own semiconductor companies, but previously couldn't because they didn't have the money. "You don't need a fab," Morris would say. "We'll be your fab." It didn't happen right away. Technologically, TSMC was starting from a long way behind the industry's heavy hitters, but they succeeded in closing the gap. How? Before the emergence of TSMC, semiconductor manufacturing was dominated by integrated device manufacturers, companies that designed, manufactured, and sold their own chips. That kind of integration made the idea of entering the market, let alone dominating it, seem scary for a new company. TSMC didn't go over the wall, they went around it. In his 2003 book, The Innovator's Solution, the legendary business strategist Clayton Christensen explained that the natural trajectory of industries was to move from integrated architectures to modular ones. Highly integrated semiconductor companies, by virtue of trying to do everything, were too big to be responsive. They were too big to succeed. Christensen went on. Whereas in the interdependent world, you had to make all of the key elements of the system in order to make any of them, in a modular world, you can prosper by outsourcing or by supplying just one element. Ultimately, the specifications for modular interfaces will coalesce as industry standards. When that happens, companies can mix and match components from best-of-breed suppliers in order to respond conveniently to the specific needs of individual customers. This is exactly what TSMC did. Specifically, Morris enabled those guys who he had come across in his previous life at Texas Instruments to start fabless companies, and in the process, engaged TSMC to manufacture the chips. Suddenly, an industry defined by vertical integration because of its staggeringly high capital expenditure and IP requirements became defined by horizontal integration. Morris had succeeded in flipping it 90 degrees. In his own words, from 1991 onward, the number of fabless companies started to mushroom. When Morris, in his role as head of Taiwan's Industrial Technology Research Institute, founded TSMC, he promised that, unlike the leading integrated device manufacturers, TSMC would never compete with its customers. That promise, which was backed up by the reality of TSMC's business model, ensured the presence of something which has been absolutely vital to TSMC's success: trust. TSMC knows that it only succeeds when its customers succeed. Its very existence is built on that fundamental compatibility of objectives. The more fabless semiconductor companies that were founded, the more and more businesses TSMC received. Its flywheel began to spin. In 1994, the year after opening its third fab, TSMC IPO'd in Taiwan at a $4 billion market cap. By the early 2000s, boosted by cornering the booming market for dedicated graphics chips, TSMC had caught up to its competitors and surpassed them. I want to take some time to explain how they did this, because this is a really important part of our story. Simply put, TSMC beat its rivals and put itself in an almost unassailable position because it maximized its opportunities for learning. Firstly, by making chips for a diverse array of customers, it needed to constantly solve different types of problems. Secondly, the more chips they manufactured, the more revenues they could reinvest in R&D. Today, TSMC has one of the most valuable patent portfolios in the world. Third, despite being spun off from Taiwan's state-run Industrial Research Institute, it wasn't shielded from competition. Morris and his colleagues knew that the only way to turn TSMC into a world-class company was to force it to compete with the world's best companies. Last but not least, they are absolutely obsessed with iterative improvements in its manufacturing process. Semiconductor manufacturing is one of the hardest things to do in the entire world. Making the most advanced chips involves literally thousands of intricate steps across dozens of discrete disciplines. The slightest defect in a machine or human process, such as a killer particle, is enough to render an entire multi-million-dollar batch worthless. Remember how I said earlier that one of Morris's big realizations at Texas Instruments was that the best way to quickly improve yields was to rapidly scale up production at low price? That insight, learning curve pricing, would remain a core part of TSMC's success. The manufacturing volume that TSMC was able to leverage relatively early on in its history enabled it to generate more data than its competitors. But this story still has a few more twists. The first is Morris's retirement. In the rush of TSMC's remarkable rise to the top of the semiconductor industry, it's easy to forget that Morris was not a young man. In 2005, he was 74 years old. He had built TSMC into something that far surpassed his wildest dreams. So he called it a day and rode off into the sunset. Morris stepped down and handed the reins of TSMC over to his longtime second-in-command, Rick Tsai. But he wasn't gone for very long. In the summer of 2009, Morris called a surprise press conference to announce that, at the age of 78, he was returning to once again be the CEO. Part of what brought him back was his belief that he was the best person to steer TSMC away from the global financial crisis. The other thing that coaxed him back was what he called golden opportunities ahead. What do you think the golden opportunity for a semiconductor manufacturer was in 2009? That's right, mobile. After the explosion of fabless chip companies and the advent of computer graphics cards, the smartphone was the third paradigm shift in consumer electronics to take place since TSMC's founding. It was the biggest by far. Apple had been selling the iPhone since 2007. At first, it sourced the critical components, including chips, from Samsung. But then Samsung decided it wanted to make its own smartphones, putting it into direct competition with Apple. Apple hated that the money it was paying Samsung was being used against it. The relationship soured even further when Apple sued Samsung for IP theft. That experience led Apple to diversify its supply chain and straight into the arms of TSMC. In September of 2014, Apple launched the iPhone 6, which had a processor fabbed by TSMC on its 20nm process. With just one exception, when it flirted with dual sourcing chips for its A9 processor from both TSMC and Samsung, Apple has stuck with TSMC ever since. That's especially remarkable when you consider the potential risks of being totally reliant on a single supplier to produce your single most critical component. But then again, TSMC isn't like most suppliers. Its determination to meet Apple's needs is a great example of why TSMC enjoys the huge advantage in chipmaking that it does. For one thing, it changed its own rollout schedule to fit Apple's relentless annual release cycle. Every new generation of the iPhone needs an improved processor. That means TSMC needs to create a new high-yielding production line every year. It achieved that by creating a modified half-step process, whereby it generated more modest performance improvements every year instead of bigger jumps every 18 months or 2 years. Secondly, TSMC is one of the very few companies that can match Apple when it comes to capital investment. In 2013, it spent $9 billion to build a fab in Tainan City that only made chips for Apple. Apple has rewarded TSMC lavishly for its commitment. In 2019, Apple paid it $8.2 billion, almost a quarter of its annual revenue. Securing the partnership with Apple was one of Morris's greatest achievements in the third act of his career. Satisfied, he again stepped down as CEO in 2013, but stayed on as chairman. TSMC's incredible scale, built on a foundation of trust and non-competition, has concentrated the chip-making industry. In the early 2000s, when TSMC finally caught up to the leading edge of technology with other semiconductor companies, there were more than 20 companies at the leading edge. By the mid-2010s, there were just 6. Today, there are only 2 firms manufacturing the cutting-edge 5nm node at volume, TSMC and Samsung. Both are planning to put a 3nm node into volume production by the second half of 2022. But before any of that, there's another milestone to cover. In mid-2018, Morris Chang retired. For real this time. He was 86 years old. It's almost impossible to describe what he has achieved. The numbers are beyond comprehension. They're mind-blowing. In 2020, TSMC announced an operating profit of $20 billion on $48 billion of revenue. Bloomberg estimates it makes $4,500 in revenue for every 12-inch wafer it manufactures. Its gross margins are in the vicinity of 50%. It has 90% market share of the current 5nm node. It's planning to spend around $40 billion on CapEx in 2023. And yet, the numbers somehow don't paint the full picture. TSMC is a story about globalization. It's a story about Taiwan's economic miracle. And it is a story about Morris Chang, a man with one foot in the East and another in the West, who built the best chip-making company in the world. Right now, it's hard to imagine TSMC being dislodged from its perch. Even if TSMC were to go out of business tomorrow, and for lots of reasons, let's hope it doesn't, it would still deserve to be remembered as one of the greatest B2B hardware companies ever. Not bad for someone who was washed up almost 40 years ago. Thanks for watching. If you'd like to see another video like this, just watch my video on NVIDIA next.